Hello, my name's Miss Harrell, and I'm a certified math teacher for the state of Tennessee. Thank you for joining my 5th grade lesson for today. Today we're going to be doing lesson 6. To help us get started, I've got a little activity for us to look at to get our brains thinking about math. On the table here, I have 2 stacks of base 10 blocks. One is green, one is blue. Take a minute and decide which stack of base 10 blocks are larger. What do I mean by larger? Which of the base 10 blocks represents the larger number? It's kind of hard to tell, isn't it, when you're looking at them stacked like this? Do you have an idea of something that might help us determine which value or number is represented here to be the larger of the two? Okay, so if we spread them out, we might be able to tell a little bit better. I think even putting like things together might help us as well. So I am going to lay these out flat, something like that. And I will do the same with the blue base 10 blocks here. Okay, now do you have a better estimate of which of the two is larger, green or blue? It's still a little hard to tell. One of the things I think might help me is to line this up a little bit better here. Line this a little bit better. I have 2 here. Now, does this new arrangement make you more confident in which is bigger? Yes, the green represents a larger number. Why? Here we have, and if we think of these as base 10 blocks, and we think of this as decimal values, remember that the flat that I'm pointing at here represents one whole. Notice that the rods represent a tenth. They're a tenth as big because it takes 10 of these to create one whole. Therefore, I could actually do a regrouping and move these 10 away and replace them with another flat. Now my pictures look almost identical. However, in the green, I have one additional tenth. In the blue, there is only 1/10. Do you think you could help me write the decimal values that is represented by each image? For the first value, we have in our place value chart 2 ones, 2 tenths, and 3 hundredths. Okay, so what decimal would that be? 2 decimal, 2 wholes, 2 tenths, and 3 hundredths. What about our second model? We again have 2 wholes, 1/10, and 3 hundredths. Again, we said that the green was larger a larger value because it contained one extra tenth. And we can see that here in the tenths place, this has a value of 1, and this has a value of 2. All right? So one of the things that we're going to be working on today is how to compare decimals based on their place value. Let's take a second and look at our learning goal for today. So let me clear off my workspace. For our learning goal today, we're going to work to understand how the value of each digit, which is what I underlined in our opener. We underlined the value in the tenths place to compare those. So how each digit of a decimal number impacts that overall value of the decimal number. For our lesson today, there's a couple materials that I would like for you to have available. Number 1, have a piece of paper and pencil so that you can work along with me as we compare decimals. Also, I found that having a place value chart is helpful for me. And also, your teacher can provide you a student packet with additional practice problems you can do once our lesson is over for today. You can do that with your teacher or another trusted adult at home. Also, for our lesson today, we have a couple vocabulary words that I want us to take a look at. Number 1, we are going to look at, revisit some math symbols that you've most likely seen before in earlier grades. The math symbols that we're going to focus on today are less than, greater than, or equal to. Equal to, you're probably the most familiar with, which are two horizontal lines, one on top of the other, which just means that two values are equivalent or have the same value. We also have less than and greater than. I remember as a kindergarten student, I learned how to do this with Pac-Man or with an alligator, and we would often use our hands. So the less than symbol goes in this direction. And I actually think of that with my hand as being an L. So if you think about your hand being upright, and if you make an L with your hand here, the less than, so the word less starts with an L, the less than symbol is just an L that's been smushed. So that's how I keep them straight in my hand. So my left hand makes a L, which smushes to create the less than symbol. The greater than symbol goes in the opposite direction and looks like this. We're also going to use the words least and greatest to compare decimal values. So for example, earlier, the green had the greatest value, the blue had the least value of the two decimals that were modeled. We also want to know the difference between an expression and an equation. An equation is made up of numbers and math symbols and contains an equal sign. An expression is made up of numbers and symbols and does not contain an equal sign. Okay, so these are our vocabulary words that we will be using for today's lesson. All right, go ahead and get your paper and pencil ready. If you need to press pause, that's fine, and just hit play when you're ready to get started. Welcome back. For our first math task today, we're going to be comparing the numbers 13,196 and 13,296. For our final answer, we're to use the symbol less than, greater than, less than, or equal to compare the two numbers, and we'll choose which of those are appropriate and put in the circle underneath for our final answer. When we think about comparing these two numbers, we want to use our place value understanding and compare each digit from left to right. Why left to right? Because we know that every place value as I move up the chart is 10 times larger than the value before it. So let's go ahead and use our place value chart to record our two numbers. In fact, I don't even have to use a full place value chart. I can just line the values up on my work page. We usually have 4 spaces to the left and 3 spaces to the right as we've been creating our place value charts, with our decimal here in the center. So if I want to write the number, let's see, I have ones, tens, hundreds, thousands. I need one more for this place value chart to have 10,000. We know 13 is a 10,000 and a 3,000. So I'm going to write my first number, 13196. We know that there is no decimals beyond that. I'm going to write my second number, 13296. Can you tell me what digit, the name of that place value, is different? Do you remember what this one is labeled? So our 10,000s both contain a 1. Our thousands both contain a 3. Our hundreds are different. In the hundreds place, we have a 1 and a 2. Now at this point, I do not need to go any further in my comparisons because I have found the place at which the values are different. So I'm going to ask myself, which is bigger? Just like we did with our pictures earlier when we had the green stack of base 10 blocks and the blue stack. I didn't even worry that they both still had a 3 one unit pieces, right? We didn't worry about that when we knew that one of them had another 10 than the first one, okay? So when I look here, my top number has 100. My bottom number has 2 100s. That means it is 100 times larger than the first number. Okay, so which of the two is larger? The top one? Okay. Nope, sorry, I did that wrong. The bottom one, because it has 200 and this one has 100. Thanks for catching that. So let's look down here. I want my less than, greater than, equal to symbols the way that, and I still do this, I think kindergartners start doing this, and they think about the alligator eating the bigger number or Pac-Man eating the bigger number. I also want to think about this as a number sentence, and I want it to read correctly as I go left to right. So if I were reading this left to right, and I said 13,196, would I say that was less or greater than 13,296? Yeah, the 100 is less than the 200. Do you remember my trick to know which way less than goes? I'm going to visualize a little L that's been smushed. So I have 13,196 is less than 13,296. Is the alligator eating the bigger number? Yeah. Okay, great job on task number 1. You ready for another one? Okay, so for our second task today, I'm going to pull in some things that we talked about yesterday, and I've wrote the numbers in a different form. Do you remember the different forms that we talked about? We had standard form, word form, unit form, and expanded form. Which form do you see written here when I'm comparing 2 thousandths and 12 thousandths? What form is that in? Good, it's in word form. As a review, if I wanted to put this in unit form, remember all you do is rewrite the word, that's the numeral part, as a number. So I could rewrite 2 thousandths as the number 2 and thousandths and the number 12 and thousandths. Okay, so remember when we write it like that, that is called unit form. Okay, the next thing that I want to do is continue following the directions, and it calls for me to use my place value chart to show my thinking. So let's read the task card together. Compare 2 thousandths and 12 thousandths using a place value chart to show your thinking. Write an expression, remember expression does not contain an equal sign, comparing these two values. Okay, expressions are made up of numbers and symbols alone. All right, so here is my place value chart. I noticed that my value has a THS on the end. A THS on the end. Where does that land on my place value chart? To the left of my decimal point or to the right of my decimal point? Are those smaller or larger numbers? Smaller. Good. So I'm going to write 2 thousandths. That means I need to put 2 items, or the number 2, in the thousandths place. Remember, this is my tenths. This is my hundredths. And this is my thousandths. So I'm going to place a 2 in the thousandths place. You do the same on your paper. Remember that I'm going to have to put a decimal and some zeros to hold the place of my missing values. So I have no tenths or 0 tenths, and I have 0 100ths. So that would be equivalent to having these two values here, 2 thousandths. For my next number, I have 12 thousandths. That means I need the last digit of 12 to land in the thousandths place. So here's my 2 of my 12. Here is my 1 of my 12. And again, I need a 0 to hold that place of the tenths to show that there's no tenths. So as you're writing that down on your chart, let me see if I can model 12 thousandths. Okay. Now, looking at your model or the place value chart, what do I have? Which of the values are greater? Right, I have more green than I do blue, right? So this value is larger. Again, I can look at my place value chart and look for the point at which my numbers are different. So far, I have no tenths. Excuse me, I've modeled this incorrectly because thousandths would be one of a cube, the large cube. So we will ignore that part. I apologize. Here I would have 2 I lost track. I have no tenths. 1 over 100, or the hundredths. I have no hundredths here, but 1/100th here, right? So 1 is larger than 0. So which of the two are larger? Yeah, the 12 thousandths is larger than having only 2 thousandths. Okay, we could actually use the blocks, but remember that when we're talking about thousandths, that is a three-dimensional shape, or this large cube that I showed you the other day. So remember this three-dimensional cube, that one piece in the cube would represent 1 out of 1,000. So one of the tiny little pieces would be 1 out of 1,000. So if I defined the big cube to be 1, my model earlier would be okay. Okay. All right. So we decided that the 12 thousandths is larger. So we've got to write an expression. Now, you can choose to put whatever number first and whatever number second that you prefer. It doesn't matter. You just have to make the symbol go in the right direction. So I would like for you to take a second and write down what you think a math expression might look like. Okay. So you could either put the 2 thousandths or the 12 thousandths first. It doesn't matter. If you chose to put the 2 thousandths first, you would need to say the expression was a less than math sentence. So 2 thousandths is less than 12 thousandths. Okay, let's write the word less than underneath, so that you'll remember that's the less than symbol. Okay, if you chose to write the 12 thousandths first, it is greater than the 2 thousandths. So your symbol would look like this. Okay. So in this one task, we've reviewed a couple old and new vocabulary words. We've talked about word form, unit form. We also wrote our numbers down here. This is writing them in standard form. Okay. And we've used our new vocabulary words for today, which is less than, greater than. And we also wrote an expression for the first time. That's a math sentence made up of numbers and symbols alone. Okay, good job. All right, let's move on to our third task for today. We have 4 total. Okay, I'm going to put this task card up, and I would like for you to take a moment, read it to yourself, and I'm going to give you some private think time to see if you can show this comparison all by yourself. Okay, I'm going to go ahead and use my place value chart. The task asked me to compare 299 thousandths and 3/10. I'm to use the place value chart to show my thinking, and I want to show the relationship with a math symbol in the space provided at the bottom. Okay, so I know that this is my tenths place, hundredths place, and thousandths place. I know I need the whole number 299 to land in the thousandths, so that very last place in my chart. So I'm going to kind of go backwards. I have a 9, a 9, and a 2. And then there would be the decimal in the front. So did 299 land in the thousandth spot? Good job. Next, I have the number 3 that I need to land in the tenths spot. So I'll put a 3 in the tenth spot and put my decimal up front. Remember that we can also, for the ones place, put a 0 there to hold the spot and show that there were no ones. Sometimes students, when comparing decimals, prefer to fill in zeros to make the two decimals have the same number of digits. So you could even fill in that the second number has no 100ths and no 1000ths. When you do that, I think it's really easy to think about comparing these two numbers. I have 299 thousandths, and I can express 3/10 as also being 300 thousandths. Okay, think about why that's true. I could lay 300 of the tiny little thousandths pieces when I think about the cube being 1,000 total. And then remember, every time you have 10 of something, you can make a trade, right? So if I have 300 of these small pieces, for every 100, I could make a trade for the next value up that's 10 times bigger, okay? So in other words, 3/10 is equivalent to 300 thousandths. Okay? Now, we're going to compare the two values. What did you do to write this with a math symbol? Some people might have kept the original problem with 299 thousandths and 3/10. And is 299 thousandths less than or greater than 3/10? Let's look here at our value where they change. The first value to the left, as I go left to right, the first time that those are different is in the tenths. So 2 is less than 3. So the 299 thousandths is less than 3/10. So what symbol did you use? The less than symbol, which is your little smushed L. Good job. You could have also wrote your final answer using the decimals. So we could have wrote 0.299 is less than 0.3 for 3/10, what we originally started with, or you could say 300. That would be fine as well. And just like on our previous problem, you could even flip those around to be able to use the greater than symbol. So for example, I could say 3/10 compared to 299 thousandths, 3/10 would be greater than 299 thousandths. So I could use the greater than symbol to write my math expression. Okay? All right, good job. We have one task to go. This one's a little bit different direction. So on task number 4, we're asked to order decimals, so not compare. We'll use comparing to help us order them, but our final answer needs to be an order. So I'm going to order the following decimal numbers from least to greatest. Now, that is one of the things that students mess up on quite often, is they'll get in the habit of doing least to greatest or greatest to least. So I always want to underline my expectations of how I'm supposed to order so that I won't forget. Because sometimes the directions might ask you to order greatest to least. So I know I'm going to pick the smallest number to list first, then the next smallest, then the next smallest, until I get to the largest. Okay, so least to greatest. We're also to explain our strategy. So I'm going to give you a second to think about this. You can look at the numbers and try to do it in your head. You can do like the student did earlier, where they like to make the number of digits match. So if this had 3 digits to the thousandths on our previous problem for 299, remember that had 3 digits, so we added those 2 extra zeros to make them have the same number of digits. So then the 300 would have 3 digits as well. So you can use the 3 digits to compare. Or if it makes you feel better, you're more than welcome to use your place value chart to help you compare. So the numbers are 413 thousandths, 56 thousandths, 164 thousandths, and 531 thousandths. So take your pencil and paper and see if you can write these numbers from least to greatest. Okay. So one strategy is to just look at the numbers. Each one has how many digits beyond the decimal point? 3, right? They each have 3 apiece. So I could start at the decimal and look to the right to see if there's any difference in my tenths. So notice in this first number, the tenths is the value 4. The second number in the tenths is the value 0. The third number in the tenths is the value 1, so 1/10. And in the last number, my digit in the tenths is 5. So if I wanted to list these least to greatest, which number has the least number of tenths? Yes, the second value, which is 0.056. Okay? What would be the second value with the least number of tenths? And I usually try to put a little check or something so that I won't lose my place. Okay? The next value with the least number of tenths is 0.164, 164 thousandths. Okay, so we use that one. I'm going to put a little check there. Next would be 0.413, so 413 thousandths. And last, 0.431, or 531 thousandths. So that's one strategy you can use to list your decimal numbers from least to greatest. You can also use your place value chart and line the numbers up like we did earlier. So I have 413 thousandths, 56 thousandths, 164 thousandths, and 531 thousandths. Okay. So again, when you have these lined up in your place value chart, you can see that 0 is the least of all of the 3 digits, which is why that we listed that number as the least. Then the 1 would be second, the 4 would be third, and the 5 would be last. Okay, so our tenths allowed us to compare which value was the least and put those in order from least to greatest. Okay, now it says explain your strategy. So I would like for you to take a second and write a sentence about which strategy you used and how that helped you solve the problem. I'll do the same as you work. Okay, remember to practice using good grammar, good punctuation. When it says explain, they want a nice sentence, just like your English teacher would want you to write. Okay, here's what I put. I said I used the 1/10 place to compare the decimal numbers on a place value chart. Okay, all right. Thank you guys for joining me today to compare numbers. Remember, what we've discovered is that each digit, for example, in the one that we just did, the tenths place, each digit of a decimal number impacts that overall value of the number. A good strategy is to take your number from left to right on your place value chart and look for those places where you first see a difference. We also use some good vocabulary today, listing numbers from least to greatest. Sometimes you might also be asked to list them greatest to least. And we used our math symbols, less than and greater than. Thank you so much for joining me today. Remember, there's a student packet that you can do for additional practice problems with your teacher or another trusted adult. Until next time, have a great day.